Hello friends, welcome to Kavita's classroom. In our previous module, we talked about demand and today's turn is of elasticity of demand. But before proceeding ahead further, a simple request, reminder, do like, share and subscribe my videos. Yes. So, my point is previously we talked about the law of demand. And when we talked about demand, it simply gave us the relationship between the price and the quantity. Right. We got to know from this concept that when prices rise, the quantities fall, and otherwise also is true. The vice versa is true. When prices fall, commodities show a rise. But it never talked about by how much. That's why we say that the theory of demand is qualitative in nature. So, how about quantification? How would we get to know that if this is the quantum of change in price, what's going to be the quantum of change in quantity? So, to have that quantitative expression, we have the concept of elasticity of demand. Right. So, for before proceeding ahead for elasticity of demand, let's talk about elasticity. What do we mean by the term elasticity? Elasticity is when we apply some force and that gives a change. Is it elastic in nature? No, it doesn't look like, right? I have just tried taking this ruffle for you. Is this elastic in nature? Yes. My point is, if this is the ruffle and I'm trying to put some pressure on it, it's changing, right? So it means whenever we're talking about elasticity, there has to be some pressure, some force, right? And that force here in this concept of demand is price. So, here in this concept, we are just trying to understand that when this force of price is exerted, how much is the quantum, the responsiveness of change in the quantity, right? So, we say that elasticity of demand is of three types, right? And the key word here is the responsiveness of quantity demanded. Right. When we, by this concept of elasticity of demand, we are trying to just check out the quantity of responsiveness of the demand for a change in some force. And that force can be the price, the income, or the cross price elasticity. Meaning thereby is when we are measuring the change in the quantum because of the change in its own price, then it is price elasticity. But when we are trying to check the change in the quantity demanded with respect to the change in the income of the buyer, that concept talks about the income elasticity. Right. But when we are talking about a cross elasticity change, what is this? Are you able to recall? We tried talking about the related goods, right? And we said that X and Y are related to each other. If they are jointly used, they are complementary goods. If they are used in place of each other, they are substitute goods, right? So when we are talking about this, it means they are related with each other. Okay. So now, when there is some change in X and the effect is seen on Y, we call it cross elasticity. For example, if the price of X changes and because of that change in price of X, the demand of Y changes, the quantity demanded of Y changes, right? So when we are studying this impact, this is under the header cross elasticity. But in this chapter, presently, we primarily would be focusing on price elasticity, which is a demand of the syllabus, right? So when we say what is price elasticity? It's the degree of change in demand in response to a change in its own price. And how do we measure it? We measure it by, though we have three methods, percentage method, expenditure method, point method. I'll try to give you the exposure of expenditure and point also, though mainly we focus on percentage, this price elasticity by percentage method, right? Now, what is percentage method? They say elasticity is equal to percentage change in the quantity demanded with respect to percentage change in the supply, in the price, right? And percentage change in change divided by original into 100, change divided by original into 100. So percentage change means percentage change in the quantity with respect to percentage change in the price. Mind you, everywhere, wherever you see this formula, you would have a negative sign just prefixed to it. This is just the symbolic notation of inverse relationship. It has nothing to do with the quantum. This gives me, a scope of talking whether if something has got elasticity of -2 and -5. So which has got more elasticity? Right, in which case you find more elasticity? This can be the question, and this is very often asked because students simply apply mathematics and they say -5 is smaller if we talk about mathematically, right? So they say -5, but no. Try and understand here, minus is simply showing you the inverse relationship between price and quantity. Whenever we are measuring the magnitude of the elasticity, we have to measure it with a figure. So -5 is bigger than -2 here in this case because minus is simply a symbolic of inverse relationship between price and quantity. Okay. Now, when we have percentage change in the quantity with respect to percentage change in price, percentage change means change divided by original into 100, oblique change divided by original into 100. 100 just gets cancelled with 100. What are we left with? We are left with delta Q by Q into, it will be reversed, P by delta P. And just to have a better symmetry, which suits, we would write minus and delta Q by delta P into P by Q. Students very often write this formula wrong, and I simply tell them, advise them on one particular aspect, that if you begin with delta Q, you would land on the right term because you know somewhere that delta has something oblique delta and then you have absolute values. So delta Q divided by delta P, its counterpart, and there is nothing same on the numerator and denominator, means Q would not have Q here. So you would have P and then you would have Q, and you write it this way: minus delta Q by delta V into P by Q. So delta means the change, right? Let me explain the same with the help of this example. Here you are told to find the elasticity using percentage method, but what's the situation? Just keep on writing. That initial price is 4, P is 4, and the initial demand is 1 cup only. So you have written initial demand means Q is 1 cup, right? If the price falls to 2, try and understand, there is a term to and there is a term by. When I say it falls to 215, it means that's the final value. And if they say it falls by these many units, it means it is giving you the change in the value there, right? So be very mindful about it. 2 means the final value and by means the change in the value. So if the price of ice cream falls to 2, means from 4 it has come to 2. So what is the change? Change is final minus initial position. Final is 2, initial is 4. So 2 minus 4 gets you -2. This is my delta P. And the demand increases to 4 cups from 1 to 4. It means the change is final minus initial, that is equal to 3 cups. Okay, so how do we apply it in the formula? Minus, again, let me write it down for you, minus delta Q by delta P into P by Q. Fast, right? So minus, what is delta Q? Delta Q means we have it 3. Right, delta P means -2, and what had been the initial values? Initial value of price is 4 and initial value of quantity is 1. Just sort it out and you would have it. How much? That gets out to be 6. So my answer is elasticity is 6. It means 6 times effect would be seen. For 1 unit of fall in price, 6 units of rise in prices quantity would be there, or 1 unit of rise in price, 6 times fall in the final quantity would be observed. This is how we go about for the numericals, and this is very often expected, right? 6, what does it mean here? 6 simply says if we are just giving it a comparison with unity, it's greater than unity. Otherwise, it can be 0.2, 0.3. We'll say it is elastic, but it is less than unity. We would be talking about the degrees later in the later on section, right? So now the question is, why should change in quantity and change in price be considered as the percentage change? Why don't we take the absolute values? A simple example. If you say, I got 10 marks, would it carry any weightage? Till I know from how much, what was the means maximum marking. So if you got 10, I'm not really able to comment it whether it is good or bad performance till I get to know that 10 is out of 10 or 10 is out of 20 or 10 is out of 50 or 10 is out of 100. Right. But if you say I got 100% marks, then it never is a point. Like 100% means the best. 10 on 10, 50 on 50, and 100 on 100. So we, whenever are comparing, we would never be talking about the absolute values. We would always be talking about the percentage change. Right? That is a relative expression and makes it more usable. Then question is, why should negative sign be prefixed? As I told you, it's only a symbolic of your opposite nature or inverse relationship between price and quantity. Whenever we have the answer -2, it means minus is showcasing the direction and 2 is showcasing the quantum. Means double effect would be seen. For 1 unit of fall in price, the double units of rise in quantity would be observed. Then we have the term slope of demand curve and elasticity of demand curve. Right. Slope, we have already read it before in the previous chapters. What do you mean by the term slope? And you just go by the simple, traditional, and universal formula. Slope is change on y-axis with respect to change on x-axis. That's it. It's applicable anywhere on any sort of curve. Right. So if you talk about this demand curve, what do you have on y-axis? You have on y-axis the price. So change in price with respect to the change in quantity here. So what's the formula of slope? Slope is delta P by delta Q. Now, do we have any relationship of slope with the elasticity? Yes, we have. I'll try to showcase it here. See, the elasticity of demand is equal to minus, but delta Q by delta P into P by Q. And what was the slope? A moment before we wrote here, this is delta P by delta Q. See, so do you see there is something relatable? Yes. Instead of delta P by delta Q, it's delta Q by delta P. Means this is the opposite of, means the reciprocal of slope into P by Q. And that gives you a beautiful expression of some numerical solution where instead of giving you the changes, they may be giving you the initial price and quantities are these and the slope is this. So find out the elasticity. You simply have to put in the values and get the answer. So the box gives you this information that elasticity is equal to minus of 1 by slope, means the reciprocal of slope into price by quantity. Now going ahead, we talk about the distinct situation of elasticity of demand. We have two extreme cases. I generally go by this expression. I tell my students that this is 0. This is, I don't know the values, it becomes infinity, right? So it is 1, right? And here this case is called less than 1 and this is called greater than 1, and these 5 are the expressions of elasticity. 0 is called both the extremes are given a prefix perfect. So perfectly inelastic, this is called. Here this is called perfectly elastic. Right. So what is left? One is called unit elastic. This is called less than unit elastic, and this is called greater than unit elastic. Right. So, and one more thing, there is, contradiction here with respect to English as a language. This is called inelastic. Inelastic when we are referring to less than 1. Right. but it has got some elasticity which is lesser than 1. If you talk about English as a language, it will say, no, there is no elasticity. That's why it's calling inelastic. No. Inelastic means less than unit elastic. It does have some degree of elasticity. And this is called elastic demand. Elastic means, yes, it has got elasticity even more than 1. Okay, you'll get to know about it little later here. So the very first is horizontal straight line, and what do we call this? This is perfectly elastic curve. Perfectly elastic means on this number line we had 0 here and infinity here, 1 here. This is less than, this is greater than. We are talking about this case of perfectly elastic demand. Now, perfectly elastic, when would you have infinity? Mathematics says if we have something, 0 in denominator, then we would land on infinity. True or false? Any value, if has got something in denominator as 0. 0 if comes in denominator becomes infinity. What is the formula of elasticity? Elasticity of demand is equal to percentage change in the quantity. I'm so sorry about this expression. Percentage change in the quantity with respect to percentage change in the price. Is this so or not? Right. Now, what is the situation if you want to show zero in the denominator to get the infinity? It means the price change is not there. It means when the quantity is changing from 10 to 20 to 30 to 100 to 400 or 400 to 20 to 3 to 2 to 1 anywhere, means when there is a change in the quantity but there is no change in price, price remains the same. So we have the reference points A, B and C where the prices are the same, but the quantities are changing. So such cases are called, this gives you the example of perfectly elastic demand. And perfectly elastic demand curve is shown with simply a line parallel to x-axis. On the opposite and on the contrary, we have another degree of demand curve that is perfectly inelastic. Inelastic means no elasticity. Perfectly inelastic. And perfectly inelastic means elasticity is 0. Now try and understand. Again, let us check out what's the formula. Elasticity of demand is equal to percentage change in the quantity with respect to percentage change in the price. When would you have it 0? If you go mathematically. So whenever we want to have something, some P by Q equation to be 0, it means the numerator must be 0. Numerator must be 0. It means there is no change in the quantity. So how do we make this curve? The quantity remains 4 irrespective of a change in the price. From 2 to 4 to 6 to 8 to 2 to 4, up or down. Whether the prices are moving up or prices are moving down, the quantity remains stable at 4. So there is no change in quantity, and when there is no change in quantity means 0 by anything, any value, say 4, say 5, say 10, will get you 0 again. So whenever we're talking about perfectly inelastic demand curve, how do we make it? We just make it a line parallel to y-axis, right? And the third case is rectangular hyperbola, and we call it unit elasticity, unit elastic. And try and understand this curve is in many books, this notation is given in curvical as well as in straight format. Like this is called a unit elastic demand curve. Right. Now, unit elasticity, again, let us check it out. What's the formula of elasticity of demand? Elasticity is equal to percentage change in quantity with respect to percentage change in price, and that's equal to 1. This is what I need, right? So it means percentage, just cross multiply it. It means the percentage change in the quantity is equal to percentage change in the price. What does this mean? It simply means if there is a fall in price by 50, there should be rise in quantity by 50. If there is fall in price by 20, the rise in quantity should be 20. So how do we show it? Why do we say this looks like this? Neither elastic, neither flatter nor steeper curve. Why? Because here, this way we can say that if this is the original point of reference, right? See, if this is the quantum of fall, we have almost this as the quantum of rise. So this curve is giving you, see in this picture given in the book, the quantum on price is the same as the quantum on quantity. Right. But when it comes to inelastic or elastic demand, then I'll use this very blank area. If I want to now show elasticity greater than 1 and elasticity lesser than 1. Now, be with me. Students do get baffled here. Now I want to show that elasticity. Elasticity, what's the formula? Again, the percentage change in the quantity divided by percentage change in the price is greater than 1. Here we want to show that percentage change in the quantity with respect to percentage change in the price is lesser than 1. So how do we show it diagrammatically? What does this mean? This will mean that percentage change in the quantity is greater than percentage change in the price. I have simply transposed the denominator on my right side, right? It means this diagram would have more of change on quantity and less on change of price, less of change on price. So this is my quantity axis. I would show a bigger change on quantity and a smaller change on price. Now join these points. I know we are making for demand. Demand has got inverse relationship, means if at this point I'm showcasing this as a point of reference, right? Price falls slightly and the quantity enhances very much. So what's the demand curve? It is a flatter demand curve, and that's how you have to learn that greater elasticity means a flatter demand curve. How do we get to know? By seeing at the picture that quantity is showcasing a higher change and price is showcasing a lower change. Okay, now let's talk about elasticity lesser than 1. How do we showcase it? Lesser than 1 means, again, put the formula. Percentage change in quantity divided by percentage change in price is less than 1. Transport this here. So it means here the percentage change in the quantity is less and percentage change in the price is more. How do we make this diagram? Now the quantity has to show lesser. I am making these 2 points. Right? And price has to show a bigger change. So I'll have this price and this price, bigger. Okay. Now, at this point of time, at this price, the quantity was this. But when the price increased to this tone, the quantity reduced just by this much. Try and understand. What are the points? These 2 are the points, and this point shows a steeper demand curve. This is what I wanted to tell you. That students mostly get to know perfectly elastic demand curve. This is it, right? Perfectly inelastic demand curve. This is it, equal to 0. Okay. When we talk about equal to 1 rectangular hyperbola, you can show it curvically or you can show it this way also, where you are somewhat showing this expression, neither the flatter nor the steeper. But when it comes to greater than 1, it's flatter. This is greater than 1. And when we talk about steeper, This is steeper, so this is less than 1. This is how we show the 5 degrees of elasticity. I hope all the concepts are pretty clear to you. Do work on the same. Get back to me with your feedback, with your problems, and I'll be there to help you out. See ya. We'll talk about the factors affecting elasticity of demand in the next video. Bye.